All right, guys, we are in part three of exponential and logarithmic functions. It's a lot of work, isn't it? But you're going to get through it. I promise you. And again, see to it that you are putting your best effort out there. I know you are afraid to get it wrong, but let me tell you, life is all about getting it wrong. Because in order for you to get it right, you got to get it wrong at times. That's how it got to be, you know? I mean, in my class, you got all the way up to Thursday to get it right. So if you make mistakes now to Wednesday evening, you good. Thursday night, you gotta be on. So let's go ahead and get through this, shall we? All right, in this video, I'll talk about transformations, log characteristics, exponentials a little bit more, logarithmic properties, and we're going to work with some equations. We're not going to solve equations. We're not going to solve equations or logarithmic functions. We're going to be solving exponential functions by using logarithms. All right. All right. This comes from the stuff I gave you guys. So I'm doing this proper again because one thing I want you guys to be able to understand. I want you to be able to read these problems and put what you need together. Because the thing is about these kind of tests is pretty much these type of problems. All you're doing is just putting it into decimals to get out the answer. And on your test, there's going to be two parts of the test. One test is going to be without decimals. One's going to be with it. And of course, like I told you guys before, we're going to have our desk facing the wall because the only thing I have to see is your back turns. I have to see your computer screens. All right? I cannot have you come to class without it. You cannot use your phones. So if you don't have um, a Chromebook by test date, I can't help you. So please, you got Chromebook, bring one. If you don't, borrow one because you're gonna need it to deal with decimals. Again, I can't allow you to use your phone because I can't see what you're doing on your phone. So that's the reason why I gotta be able to have the computer to watch what you're doing. All right. So let's do this problem. Although we did it in class, but we're going to do it again in the video because, as I told you before, there's no, is this right? Is this right? Tell me if I got this right. I'm not doing that. I'm not working problems that you just don't feel comfortable doing. Even if you are uncomfortable, do them anyway. So therefore, we have something to talk about next class period. I know I gave you guys a lot, but I need for you guys to get it done and to, even if you don't know, put a number. Give me something. So therefore, when we come to class, we have a discussion and we could get you ready for your test. With that being said, let's move on. The exponential function of f of x, which guys, if you didn't know this by now, f of x. See what's going on with my pen. Oh, that's why. F of x is the same thing as saying y. These are equivalent, all right? So f of x, 84.5 million. And I just say million because you're dealing with populations. And populations are always in a million. You have this number in the decimal 1 to the 12,000th raised to the power of x model the population of Mexico in millions after 1986. All right. So without calculator, they want us to set this up. So let's set it up and let's see what we could get while using the calculator. In the event that you do not have decimals, I probably even decided not to allow you guys to do that. I'll probably just give you a calculator, let you figure it out from there. So you may not have that opportunity. All right. So let's go ahead and do this. So again, it depends how I feel if I want to use decimals or not. So guys, anything to the power of 0 is what? That's right, it's 1, which is 84.5. And you're talking about millions, so you could just give me a complete statement. So on your test, I do expect sentences to go with these numbers. So guys, estimate the population to its nearest million in the year 2000. So you're going from 1986 to 2000. You gotta be able to know the years of that to get that answer. So let's do it. 1986 minus 2000. That's just 14 years, yeah. So 84.5 times 1.012 to the fourth 10 power. Now, I think when I see more questions like that, I think I'll be more prone for you to use some decimals. So that's fine. So again, it may just vary. So part C, and we did part C before. Well, we did the whole problem before. So guys, the year is 2022, right? So let's subtract 2022 from 1986. So 1986 minus 2022, that's 36 years. So you notice that I did not solve any problems but the first one, or evaluate it. Only because, again, some of these you will need decimals on to figure this out. So most likely you're going to have a decimals aspect to it. But again, I have to be able to watch what you're doing on these computers. Just so I know no one's doing something foul. All right. All right, people. Let's go ahead and make this happen. So to deal with this function, because this looks like a transformation, you start out with f of x, but you end up with the g of x. So you could describe it. You know that it went down 3. Down 1. And you know it went right 3. Left 3. And we know that it flipped. All right. So you don't really need a calculator for this. So let's talk about the original, 2 of x. So we know the basic characteristics of this. The main R real number, range, 0 to infinity, horizontal asymptote 0. The y-intercept is 0, 1, or when y equals 1. So we got all that together. So ideally, you could actually try to graph it, but the g of x part. But what I like to do personally is just do what I've been doing, filling out the tables. You know how I did the other videos? If you haven't watched that, please go back and watch part 1 and part 2. Well, part 2 mainly for this. So, this is the function. I'm doing g's of x. So, why do I not start off with 0 as always? Right? I'm erasing that because I'll come back to later. Come back to that later. So 0. So I get negative 2 to the power of 3 minus 1. So 2 to the power of 3 is 8, but because we have the negative in front of it, it becomes negative 8. So negative 8 minus 1 is a positive 9. I mean negative 9. So that's right there. If I was to include a positive number, the graph is going to be further in terms of y, smaller. Because if I was to plug in 1 here, just to show you, so negative 2 to the power of 1 plus 3, which is 4 minus 1. So that's negative 16, because 2 to the 4 power is 16, but you have a negative number out front of the base, makes that negative. Minus 1 is 17. Now, had this would have been in the parentheses, that would have been a whole different thing. All right? So remember, unless it's in the parentheses, that base is going to remain negative. And keep in mind, this is best utilized when you're dealing with transformations. So I know you guys are doing this in decimals at home, which is fine. And when we're doing class, it's going to be real easy to deal with. All right, so let's do this. So we get negative 16 minus 1, and that's negative 17. Right? And you got any further questions about the whole exponent thing when it's a negative base in front, and how even with the even power it's still negative? We could talk about that more personally outside of class. So let's not waste too much time with those further explanations for that piece. All right, so I'm not gonna go no more of the positive numbers, because if I keep going, my graphic gonna be whatever. So let me focus on the negative numbers. So instead of positive 1, let's do a negative 1. Oh, Lord, who is bothering me right now? So let's do it. So guys, 2 to the negative first power plus 3, which we know that's to be 2 to the power of negative 2, plus 1. I mean minus 1. So let's go ahead and work this out. So I know you think, oh, two negative makes a positive, but guess what? Still gonna be negative, but it's gonna be -4. And again, this does not have a parenthesis around, so it won't work in terms of making that a +4. So -4 -1 -5. Now we're getting somewhere. Now graphics could be easier to go at it. So I chose 1. All right. And that's actually -5, not +5. All right. So let's go ahead and use -2. So for -2, so I get -2 plus 3, and that's 2 to the negative, 2 to the first power, positive first power, -1. So that's still going to be -2, and that's going to be -2 minus 1, which is going to be -3. See how easy this is becoming for us? All right. Are we ready to draw a shape? Or should we do one more? I guess we could do one more and be done with it. So let's do it. -2 to the power of 0, of -2 plus, well, -3, sorry. -3, my next term, plus 3. And we know for a fact that boils down to -1 because your base started out with negative, you're going to end up negative. So -1 minus 1, that's just -2. So with that being said, I can finally draw my graph. You don't have to be perfect of anything like that. All right. Now we pretty much drew the graph out. Again, that's without decimals. So, and you may have something easier on your test to deal with. So, we know about the transformations, which we already talked about, but that is how you draw your graph. Again, I'm trying to get used to my technology, kind of struggling with that a little bit, but I'm going to get better with it. So that's how you do it, yeah? Just like that. All right, guys, for this little definition of an exponential, well, this is a natural exponential function. This has the same exact characteristics of an exponential function. And of course, you gotta know this definition because I'll be asking you on your test mainly about the definition of this and about how it has the same exact characteristics of a regular exponential function. All right. All right, guys. So use this. We're gonna use this definition for logarithmic functions. And we're going to make sure that we get it together. But before we continue, let's review to understand what it means. So let's go ahead and work with the exponential function that we know. Well, not function, but something that exponent. So let's do 9 to the power of, 3 to the power of 3. That's 27, right? So that's exponential form, but if I'm going to exponential to log form, it's going to be log with a base of 3. My base is going to be placed right there. All right, that's my b, y'all. 27. So let me pause here for a second. The log is asking you 3 to what power gives you 27. That's what the logs are saying. A base to what power gives you that number you got next attached to it. And that is a power of 3. 3 to a power of 3 gives me 27. So that's all we are saying. That's all we are doing. All right? All right. Guys, we're going to graph this function and we're going to figure it all out. Now, we know that a logarithm is the complete opposite of an exponential function. So that means, in terms of its opposites, instead of having a domain of all real numbers, it's going to have a domain of 0 to infinity. The range, on the other hand, is going to be all real numbers. All right. Now, instead of it having a y-intercept, which that's for exponential, you're going to have an x-intercept of 1, 0, or when x equals 1. All right. Instead of you having a horizontal asymptote, you're going to have a vertical asymptote. The vertical asymptote is going to be 0. So now, again, without decimals, let's go ahead and put this together. In terms of, let's plot points and graph stuff. So x and y. Now look, my students, I know you guys are all about, I gotta get it right. Chill, relax. You get it right on your test day. Cause look, at times when I teach you guys, sometimes I get it wrong. Most of it's on purpose, but just a little bit because I really at times so busy addressing you guys questions to a point that I sometimes lose track of what I'm doing. And then I'm like, oh, okay, something's not wrong. I mean, something's wrong, so I have to fix it. But I'm not afraid to make that mistake. And I thought by me, showing you guys that it's okay to make those mistakes, you'd be more comfortable if into it. You know, my class is all about, okay, when you make a mistake, learn from it, pick yourself up, do something better, because when you get to life, it gets like that. So let's get back to it. So let's go ahead and get started. All right. So the 2 is my base. The x is just that. And so what we're trying to do is find right? So let's see what happened when x is 1. Let's just start off there and see what happens. So log 2 to 1. 1 is the outside. Alright? So what I'm trying to find out is this exponent. So guys, going from there. So if I have the base of 2, what power, 2 to what power gives me 1? 2 to what power gives me 1? Well, you know for a fact that going to your law of exponents, anything to a power of 0 is going to give you 1 all day, every day, if your base is positive, of course. So that's 0. Alright. So let's go try 2. So your question is, if I have a base of 2, what is the exponent that's going to give me 2 for my final answer? 2 to what power gives me 2? Well, you know that anything raised to its first power is going to give you the identity, which is 2, or itself as we call it. So now be careful with this, because for a moment I was about to trip. I was about to put 1 there. Remember, y is at the top, and you're trying to figure out what y is. So when you put this in exponential form, mind you, it's going to be 2 to the power of y equals x. So you're asking yourself, what exponent, what power gives you the x value? So I know it's tricky than what we're used to, because we're used to just plug in x and just get y like that. So y have to equal something. All right. So let's do one more. And we could go to a negatives if we want to after this one. Because ideally, I just want you to learn how to, just plot this out. So 3 to be my x, right? So I want you to take a moment to kind of figure that one out on your own for me right quick. And you could use decimals if you want to. If you did decimals already, that's cool. If I'm on your test, you're going to learn how to do this by hand. All right. Well, let's go ahead and do 3. 3 is a little difficult. And here's why it's going to be a little bit difficult for 3. Because when you think of 3, at times you may end up with decimal points. And that's what makes logarithmic functions the hardest to kind of plot by hand. because of that. So let's go ahead and do this. So I don't know the exact number. Again, I don't have decimals to look at the moment, but I'm pretty sure I could get it close. So 2 to what power gives me 3. In my head, you're going to get the decimal point of 1.5. I don't know the details of it, but I know it's 1.5 because if I was to go to 4, which I said I was going to stop at 3, but 4, because I know how to work 4. So 2 to what power gives me 4? 2 to the power of 2 gives me the power of 4. Because from there I do get 2. Alright, so let's do some negative numbers. And then from there, let's go ahead and move it along. Keep it pushing, because we got other things to handle. Alright, so let's use just -1. So 2 to what power gives you -1? I know if you did look at decimals, for a fact, again, we're not having it, you're going to have a term that says undefined. Let's explain why it is undefined. Because A, you got to look at your definition. X got to be greater than 0. When you're dealing with logarithmic functions, X always got to be greater than 0. Otherwise, guess what? It doesn't happen because 2 to what power gives you -1? You can't think of any. So guess what? Does it exist? -2. Does it exist? -3. Does it exist? So it just keep going, going and going just like that. So now, with that being said, we could apply our points. So let's do it. So 1, 0, 2, 2, 3 and 1.5, oh god, and 4 and 2. Oh, I drew that wrong. That's why. Hold up, pause for a second. We gotta fix this right here, this 2. I think that's wrong. So let's look at this. Exactly. Call this. See, this is just case in point. Even I make them. But you see how I was able to just catch it or whatnot? So I was telling you guys that over here for this 2, when I plug in to get Y, I get 2. Let's find out if that's true or not. So 2 to what power gives me 2, or my identity? 1. So let's go fix that right quick. Bam. Now we got something going on. Now we could do it. So from 2 is 1. 3, 1.5, and then 4 to 2. So it looks something like this when you draw your points. Again, y'all know I can't draw. There. Something like that. And you know that it doesn't, it gets close to 0 but never touches. Because you keep going, it's going to become undefined. So it's not going to never touch 0. So that's why we could see the vertical asymptote to be 0. So this is what you got to do. All right, people. If you need to take yourself a little break, pause this video. It's going to take you a break. And I'll see you in 5 minutes. Otherwise, I'm going to keep it trucking. And be about your business, people. All right. So, guys, properties of exponents, all this stuff, this is just something that's going to help us use the information we need. And that's pretty much just it. So, guys, let's evaluate some laws involving properties of itself, or inverse properties, as I should say. So, y'all ready for a little fun? Let's do some inverses. So, guys, 5 log 5 2x. Let's use our inverse properties. So it looks like this one. So guess what disappears? And we're left with just 2x. See how fun that was? Well, let's do another one. Let's do this one. But before I continue, I wanted to share something unique about log that we didn't talk too much about. So guys, when you see log by itself, when it looks like this, it's saying that it has a base of 10 to x. So anytime you see log by itself, you will always assume that it has a base of 10. If it's not given to you, it has the base of 10. So log x, again, is essentially b to whatever some number we try to find equals x. And that b in this case is 10 because it has a base of 10. Remember, when you see this by itself with no number at the bottom, it has a base of 10. All right. So let's do it. So I have 10, right? But I also have log. So it's not a subscript. You don't see a subscript anywhere. You have something that looks like this. So guess what? Again, because log by itself is understood to have the base of 10, you could pretty much just say this. 10 log, which it does have a base of 10 by itself. 3 to that, and that cancels out, and that is just saying that is a third root of x, and that's it. That's all you have to do for the inverse properties. Okay? And that's essentially all you gotta worry about in terms of those things. All right? So let's do one where it is involving one, and then let's solve some equations. That I'm gonna leave this information on the board, and so therefore we could keep going. All right. Again, I know that I gave you guys a lot to do. However, the beautiful thing about this is just that when you do all of those, I promise you, you're going to be so proud of yourself. You're going to feel a certain way by the time you leave my class. You're like, man, that Howard, I don't like him. He's a bad teacher. But one thing that I did do with him, I feel confident in my mathematical skill. And that's for those who are really come to class given the effort that is. If you haven't gave me nothing, well shoot, you're gonna hate me always. Alright y'all. Let's keep it trucking. So let's do something like this. Log 20 to 20 to power of 3. I'm using this right here. Guess what? All cancel out. Bam. And again, we could explain that. We could go far with that. So I had 20 before, right? I'm going to take what I wrote, log 20 to the base of 20. Well, log with the base of 20, and 20 equals 1. And if I go to exponential form, the only thing is just saying 20 to the power of 1 equals itself. I will be asking you to do some evaluations of this. So please keep up with that. Be responsible for that, all right? All right. Let's evaluate just a little bit. I don't know I told you not to evaluate these logs, but kind of want you to try it anyway. Let's see. Well, we've been evaluating logs, so let's just do one for fun. So, guys, log 25 to the power of 5. What is that? What exponent would give me that? Well, actually, I wrote that wrong. I'm tripping. It's the other way around. So it's log 25 with, with 5. And the answer to that, of course, is 2. All right, let's do another one. I promise you, y'all gonna be feeling so good about yourselves on the test. Y'all gonna be smelling yourselves. I can't tell y'all anything. Y'all gonna be y'all gonna be too much. I will tell Mr. Bester I made y'all like that. That's my fault. I'll be proud about it. All right, so guys, with a base of 8, any powers that you know gets you 8? Oh, I'm tripping again. See, I'm tripping right now. But you see how I'm not afraid to be okay to trip about it? You know? So, guys, I know for a fact the answer to that is 3. Because, guys, 2 to the power of 3 gives you 8. So, bam, just like that. And that's all you guys are going to be doing. You'll be doing it just like that. All right. Oh, let me do one hard one. I promise, one more hard one. I'm going to let go of this part. All right. I'm trying to pick a good one, too. Ooh, I know how to do this one. So log. And doing it while I calculate that is. And of course, these are the kind of things you're going to see. So yeah, what is that? So 5 to what power gives me that 1 over 25? What do we know about that? We're using your law of exponents. Let's go back to it. So something looks familiar that we know. Shablam, right there. So we know that's to be a negative exponent. So that'd be the negative exponent of 2. Give me 1 over 25. Because 5 to the second power, we know for that is negative 25. And we just write that as a fraction as 1 over 25. And that's all you gotta do, people. All right, we done with that. But I'm still keep these properties around for you to deal with. So we're gonna solve a few equations. And then we finally gonna pull the rest. You guys have been so awesome keeping up with me, dealing with me, and I just don't know how to say thank you guys. I'll plan something nice for you guys for rocking with me this long. All right. So let's go ahead and do us in some fun. I'm trying to pick something fun to look at. Finally, I saw some equations. That's what I'm gonna do for y'all. I'm gonna go ahead and solve these equations for y'all. All right, here goes something. I know you guys get this wrong, get this confused with the natural log. All right, so when you're using log, the original log, not the natural log, this is only for when you have exponents. I mean, when you have bases with the power of 10, because they cancel out. Because remember, when you're solving equations, you're already canceling things out and you're solving for x. So let's go ahead and do that. So guys, let's do 10. And now I'm being creative here. I'm making things up. X over 100. Which I know this is just for us to be just the answer to be 2. So we could, figure that out all day, every day. But I just want to go ahead and work things out so we could get things together. So for this one, it's x equals 2. Because we know that 10 to a power of 2 gives us 100. So what if I decide to go with a different number? 120,000. All right. And this is some trick stuff that we are doing at this moment. This is trick, but we ain't gonna go too far into it because, like I told you guys before, you're going to see this exactly again. So it starts in Algebra 2. So let's do it. So guys, remember, you want things to easily cancel out. So when you see log, let me rewrite this in a different color. So when you take log of this side and you do log here, this goes away because remember this is understood to be log with a base of 10. So that goes bye-bye. And you got x right there equals the log, what you left with, 120,000. Now, again, on your test, when you're solving these equations, because you don't have the calculated features of this, so you're not really solving them. Well, in my class, I won't have you to solve, more like set up. You could do that. Now, I will say this: if you got some true skill and you can make those calculators that you have work, hey, bonus points to you. I'm going to try practicing with those calculators in the classroom before you guys come to my class, and then I'm gonna show you guys how to put this in the calculator. I may, if anything, just give you a cheat sheet of how to put these logs into your calculator. All right. So, what if when the base is not 10? What if I have something, and y'all seen this before? I did this before. That's when you take the natural log because your base isn't 10. Because you use log, nothing won't really cancel out. You have more stuff to deal with. Remember, when you're solving for stuff, you try to, get it together and out of the way. So here, you got the ln, well, bring down your x, ln of 4 equals ln of 15. Well, from there, divide it both sides by ln of 4. That cancels out, and you are left with that. So x equals the log natural of 15 over 4. I could condone that too. Or you want to be, accurate further, ln of 15 over the ln of 4. That's fine. Again, I'm not asking you to put this in the calculator because, A, you really don't have the calculators that will do those logs properly. So we're going to leave it as that. All right. So we solve equations when they are not like that. All right. And remember, we're not going too far with this. Now make sure that we are not. So let's deal with the equation that looks like this. Now I'm about to put on the board. Again, I know that I told you not to do that in class because I want you to get the basics down first. But when we talk and work things out on Tuesday, I may make you do one or a few of those, and you may see something like that on your test. May or may not. So let's go ahead and do it. So you get 40 e.6 x minus 3 equals 237. Or I wrote 234. I could leave it at 4, but let me do 7. So let's solve this equation. So before you take any natural logs, because you got a natural exponent, although you do have a base of a 10, because 40 is 10 times 4, but because you got that e there, you're going to use the log natural. And again, have e not existed, you will use the regular log to solve that. So let's do it. So add 3 to both sides. And you get 240 equals 40 times e to the power of 6x. Now, because you're dealing with e's and stuff like that, you're going to have to take natural logs and all that stuff. So guys, 240, so you're going to have e to a 0.6x, and you're going to have 240 divided by 40, because you're going to have to divide stuff out. All right. And you're going to be left with 6. So e to 0.6x equals 6. Now, we're not finished yet. We're almost there. To get this taken care of, guess what you're going to have to do? Natural log both sides, and when that happens, you get 0.6x equals the ln of 6. Now remember, you still got to get x by itself always, every day. So divided by 0.6, 0.6, and your x, your final answer should equals ln of 6 over 0.6. And again, I'm not too worried about you guys plugging that in. If you did, kudos. If you didn't, that's fine. But getting it set up like that, that's fine. Because when you get into pre-calculus, hopefully you have what you need to kind of answer those questions very good. Like in terms of give me the specific value for x. So again, you will see this in pre-calculus, people. But they should have the calculators needed for you to give me the specific values of ln's. So, all right. And again, I saw these type of equations before, but I just wanted to kind of just, give you some more practice, just show you a little bit more. But that's pretty much just it. All in a nutshell, what we doing. So it shouldn't be that hard, no? I know it's a lot being thrown at you, but I promise you this, y'all. You guys gonna have it together. And that's just it. So thank you so much for rocking with me. Please watch these videos as you work out these problems. Do not come to class empty-handed, and you should be all right. If you got any further questions, reach out to me. Do not forget to attend my 2 tutoring sessions if you want those 100 points added to your grade. And please, 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 again, don't come think I'm going to give answers, because all I'm going to do is just close tutoring and just not think nothing of it if you are trying to get answers and not show me what you do know in the tutorings. All right, toodles.